So KPC asked a wonderful question on Twitter recently, and the question was, which supply chain attack was mitigated in this change and how? So I gave an answer, but I wanted to walk through the rationale behind it from first principles if possible. So the change is here. And what we see is a PKG build file, allegedly from an Arch Linux package. It's basically describing how to build this package from its sources. And as you can see in the diff, there are some things that have gone away and some new things that KPC is proposing in this change. So I'll give it a quick scroll, and I see obviously there's two materials being added right here. There's two PGP public keys that are added, so these are new, and that's the first thing that kind of stands out. There's the two things being added to the source package definition, and they seem to match these two things right here. These two named files right here in this list. And we would assume that this checksums right here also match those two. But what about this first line? What about this first line that used to say git plus a variable called URL dot git, then hash tag equals v, and then another variable that's interpolated here, the version number, and then the attribute sign. That went away, and it's now a file, a tarball with name dash version, and then specifically seems to be indicating where to get it from, which seems to follow the convention for GitHub release download files. There's also this addition here. There's a new build dependency called auth-tarball-from-git. And so what is this thing actually changing? So if we only, I don't know anything about Arch or how packages are built, but if we go only by this particle right here that says sign, it looks like there was in the fetching of the source, it looked like we were interested in the signed aspect of that, and it seems like that has dropped from here. But then the question is, do we get it back from this build dependency auth-tarball-from-git? So how to go about it? The first thing I would do here is try and find what this string here means. What is this, let's say, URI convention here, git plus url.git hashtag, etc. I have seen this kind of things before, as probably so have you, when you git clone and then you have, git plus and then a protocol and a full GitHub URL. And then it ends with .git for the name of the repo, and then there's the hash and the tag and the sign. That's what kind of throws me off a little bit. Is it a GitHub thing? So I went and searched for that first. That's first what I did was basically I used terms like GitHub, git clone, and then I was looking for things like signed, and I wasn't really getting anywhere there. So it looks like this wasn't a GitHubism or a Gitism. Started sounding like it could be an Archism. And what I did to try and figure that out is I was looking at this part that says signed right here. So PKGBUILD, that's the next kind of search I did was, PKGBUILD spec, and trying to see what is this, what are the semantics of this thing. I am familiar with, Debian and Ubuntu source packages, but not so much with PKGBUILD. So what does this do? And specifically, I'm looking about kind of like the action happening on their source. So I was looking here for source, where can I find information about that particular thing, and I get it right here. And it's saying basically it's an array of files needed to build a package. It must contain the location of the software source. In most cases, it's going to be an HTTP or FTP URL, and I can use string interpolation to get the package name and the package version. All makes tons of sense, but still doesn't explain what kind of that signed is. Now here there's a tip here that says see using BCS sources and BCS package guidelines for details on BCS specific options such as targeting a specific Git branch or commit. And now this starts to make sense because what I'm sensing this does is that it clones a repo and then it's switching to this tag, and it's looking for that sign tag. And so I'm gonna open those two things. So PKGBuild basically describes the syntax of this thing. So it doesn't get me too far. It basically just tells me, yep, there's going to be a concept of a fragment, and it's going to allow for a specific kind of branch. It is, of course, supporting multiple source control managers. In the case of Git, tag is a specific one, but let's say in Bazaar that wouldn't exist, or in Subversion that wouldn't exist. But anyway, and now here's an interesting one, query. So this thing that says query right here, it basically says it allows specifying whether this checkout should be checked for PGP signed revisions. The source line should have this format. Currently, it's only supported by Git. All right, so now this gets me kind of close. Now, how does that thing happen? How do we check that signature? So let's look at this other piece of documentation here. So again, I get the same kind of information about the fragment. It goes a little bit more into that detail, but not that much. I'm gonna search for signed in this doc. I don't get anything. I'm gonna search for signed in this man page. So this already tells me something interesting. It says, look, there should be another attribute of PKGBuild called valid PGP keys, and it's an array, which is the PGP fingerprints that I'm going to use for validation. Okay, so that tells me these things are kind of linked, but not too much. Here's the other section I was already reading, and then here's the section valid PGP keys. So I jumped from here to make PKG, like as the tool that would consume this file and output binaries on the kind of other end. So very naively, I was kind of looking at it that way. So I went and looked up GitHub make PKG. I understand that's not where GitHub is not where development for this happens, but it does provide kind of an easy way to try and search for the source control for this. So I seem to get a link here, and I'm going to a GitLab instance for Arch, and then I seem to have here one file that composes make PKG. So then I can start kind of looking for signed in this, in this code base. But of course, I'm going to get a lot of kind of extraneous stuff. And I sense that the question mark is not going to help me that much, because it's only kind of throwing that same man page I was reading earlier. So what I would do is just search perhaps for valid PGP keys, and let's see if that gets me any closer. And I'm going to ignore everything that's docs. It looks like this is the proto file for the PKG build, so that doesn't help me either. But here I'm getting into something interesting, and there's a live make PKG, and then there's an integrity folder, and there's a verify signature include file here. And it looks like I'm kind of comparing valid PGP keys with different things, basically allegedly kind of the signatures that I got from validating something. So I'm gonna go explore this one. And so here I'm gonna look for my signed tag, and there you go, I get query signed. So that's the attribute that I'm kind of looking for there. And there's of course all sorts of case handling here for parsing things, but mostly interested in, there is obviously a function called verify get signature, and what this is doing allegedly is after checking out the fragment locally, it's looking for the verify fragment type commands over this, and there's also the status file that sounds like I'm outputting to that status file, and I'm looking for new signatures in that status file, and I'm gonna parse this, and I'm gonna finally do the comparison with the PGP keys that I have here. So going back to the change set, sounds like we were checking for signatures here already. So what is different about this one, about this particular change? And what I could gather is that we're being more deterministic about the inputs. Instead of pointing kind of a flimsy PKGBuild spec specific syntax for the repo, and then an entirely source control hosted source control manager is in control of this thing, right? So that URL, it's basically putting someone else in control of this thing. And then so is the tag, which is kind of inherited here. Basically, what could happen here is that the upstream maintainers of this, so the people behind this repo right here, they could, seen as Arch has taken, let's say, version 0.10.1 and it's building based on that tag, they could just force the point this tag to a different commit that has unexpected inputs for this build process and produces you know, malicious, potentially malicious binaries. And they could do so even passing the PGP key validation because they could sign that commit as well. The problem is that we never had a, let's say, a proverbial hash for this. We never had a hash for this. We only were looking for the signature. So the integrity of that was okay. The signature of that, if we trusted the identities of these two things, that was also okay. But this could change from underneath us. It still be, still have integrity. It still be signed by these keys, but we don't really have a kind of a hash for the inputs. And so that's what's changing here. I am using a tarball, which comes from, so instead of checking out the source control, I'm using GitHub's native ability to kind of download a release. So I'm basically using kind of this URLs right here rather than, doing a checkout. And I have a hash for that. So then the question is, have we lost the signature validation? Now we just have a hash for a tarball, but do we know who signed that stuff? Have we lost the value of those signatures? And the answer is no, because we have auth-tarball-from-git. And so this was the other part of this. So basically, if you look at KPC's repos, you are going to see, struggling with navigating GitHub today, but basically you are going to see that there is a work recently done in the auth-tarball-from-git. And what this does is it uses the fact that git archive is a reproducible operation. So as explained right here. And basically now you can get a tarball from arbitrary releases like right here. You can get the key. You can still kind of just pass a fingerprint to one of those services and just get that thing. And then you can do a local operation, which is auth-tarball-from-git. You can point to the fingerprint, you can point to the tag, and then you can point to the repo and tarballs, and it will check out. So checks out the repository, switches to the tag, verifies the tag, reproduces the archive, and then compares the archive produced locally with the archive downloaded, and then you can just go ahead and use it. So that's what this does. It doesn't add signature verification for the tag because that was already there. What it's adding is being deterministic about the input. So it looked like in the previous model we were trading off the signature validation for the kind of having deterministic inputs for this, and now that's what we have here. Now we can argue a lot about how to go about this. Like, do we need to check in these two keys here? Could we extend, for example, this method called, what is it there, the valid PGP keys, kind of piece of shell scripts that do this comparisons? Like maybe can we save auth-tarball-from-git that step? Maybe we can download that locally through the existing kind of mechanism here and just pass it over to auth-tarball-from-git. So those would all be interesting kind of things to do. For example, I can inspect if make depends contains auth-tarball-from-git, and then I can change the behavior perhaps of valid PGP keys so that it passes those things, and so I don't have to have 3 checksums here but just one, which would make sense, and then I don't have to have these 2 files. And again, the value of this is you don't have to make the trade-off. You can do 2 things. You can say, hey, what I thought was 0.10.1 now actually has a SHA-256 checksum, and that's, I'm kind of pinning to that formally, because here's what you lose with this is basically you lose the pinning. So if you want to read KPC's write-up on this, just keep scrolling down the thread with the trivia question, which by the way, thank you, it was fun. And here's a blog post where they talk about verifying tarballs with signed git tags, and that's just a kind of fun thing to do. And I thought it was an interesting thing to maybe walk you through this, because the taxonomy of this whole space of open source supply chain security and reproducibility and whatnot is very rich, and sometimes it's not super clear if the kind of differential analysis of a change set like this immediately, throws the answer. It took a little while for me to go learn a little bit how, what PKGBuild was, how it was doing the signature validation, where in the make PKG world, which by the way appears to be just part of the Pacman repo, so that's fun, where all of that happened, and kind of reinforces that a lot of this is ecosystem specific in a sense, meaning that it's going to have slightly different solutions at slightly different timelines for different ecosystems. Anyway, thanks for keeping it fun. Thanks for watching. And if anything, just drop me a comment here.